Hello, and welcome to an AES Drilling Fluids Tech Tip. Drilling fluid lubricants are widely used to help with friction-related drilling issues. They are used in both water and oil-based drilling fluids. Lubricants are often confused with other drilling fluid additives, such as friction reducers or ROP enhancers. Lubricants are materials that reduce the coefficient of friction between surfaces. There are mechanical lubricants, such as solid materials like nutshells, beads, or graphite. Nanoparticles are also mechanical lubricants. There are also surface agent lubricants, or liquid lubricants, which are chemicals that have an affinity for metal surfaces. These materials generate a film to coat surfaces and lower friction. Some lubricants are soluble and mix completely in the base fluid, partially soluble, where one or more components are dispersed in the base fluid, or encapsulated in solid particles and applied when the capsules rupture. Lubricant testing and validation can be summarized in 3 stages: compatibility testing, lubricity performance, and a rig trial confirmation. Compatibility testing involves checking the lubricant under varying conditions, such as pH, salinity, temperature, drilled solids, and full mud formulations. Cheesing and greasing are common signs of lubricant incompatibility, where cheesing is indicative of an undesired emulsion induced by a small amount of oil, calcium, and water. Greasing occurs as solids within the fluid become oil-wet due to the lubricant chemistry and other properties of the fluid system. These issues can wreak havoc on a rig site, especially with solids control equipment. Jar testing is part of compatibility testing, in which many iterations of lubricant candidates are exposed to varying conditions, and visual signs of incompatibilities are noted. It is also necessary to perform full mud checks on fluids with lubricants to determine their impact on fluid properties, such as viscosity and fluid loss. Some lubricants can significantly impact these properties, making them unsuitable for use in some drilling fluids. The next stage of lubricant qualification is performance measurement. Most lubricity meters attempt to measure the coefficient of friction in a given fluid. The goal is to get a good baseline measurement of the coefficient of friction in an untreated fluid or control fluid. Once that is captured, lubricity runs are performed in which a given percentage of lubricant is added to the base fluid, and the resulting coefficient of friction is measured. It is important to test lubricants up to and even beyond their practical concentrations in the field, to understand where the coefficient of friction reduction is no longer achieved with increasing lubricant concentration. Some lubricity meters have the capability to vary the surface against which the force is applied, such as varying grades of steel, formation materials such as sandstone, or actual steel tubular such as casing. The final stage of lubricant verification is field validation. Regardless the amount of testing that is performed in the laboratory, field performance is the true measuring stick of a lubricant's effectiveness. Proper tracking of drilling metrics in coordination with lubricant additions is the best way to track performance. That concludes this AES Drilling Fluids Tech Tip. Stay tuned for the next one. If you want to learn more, have a listen to the Flowline, our podcast. And if you want to improve your drilling fluid performance, reach out to us at AES Drilling Fluids.